Algebraic vectors, we're going to learn about some operations that we can do with vectors. We've talked about what a vector is. A vector is an array that has magnitude and direction, just like the guy off the movie Despicable Me. His actual name is Victor, but his evil villain name is Vector, and he calls himself Vector because his plans have both direction and magnitude. They're big in nature, and they're going in some evil direction. So that's why he calls himself Vector. Anyway, I like that reference. I like that movie. So anyway, what algebraic vectors are, since all vectors of the same magnitude and amplitude are equal, it's oftentimes easier to express their vectors in order paired with the initial point being the origin. Now we talked about in the first section that a vector that's, say, up here and going in this direction and down here going this, as long as they're the same size and they're going the same direction, they're equal vectors. We can move vectors around. It doesn't matter technically where they start and where they end. All that really matters is their direction and their magnitude are the same. So if the direction and the magnitude are the same, we can move them anywhere. So a lot of times it's a lot easier for us to visually see things from the origin. And what we're going to talk about today is writing a vector, say from this point to this point instead. All right, it's going to be the same size vector going in the same direction. Like I said, we're going to start with its initial point at the origin and its terminal point at this point that we get here. Okay. So it says represent a vector as an ordered pair. Suppose there's a point, point 1, xy, all right, is the initial point of a vector, and point 2, another ordered pair, is the terminal point. The ordered pair that represents this vector right here with the arrow above it, that means vector, point 1 to point 2, is the second x value minus the first x value, the second y value minus the first y value. Now this comes up quite a bit in your math career. A lot of times when you're doing the distance formula, you subtract the second term minus the first term. Like if I told you you started at the 30-yard line of a football field and you ran to the 60-yard line of the football field and asked you how far you went, you say, well, I ended at the 60. 60 minus 30 is 30. I went 30 yards. All right. That's what a lot of you guys would do to figure out how far you ran. So when we're talking about distances and stuff like that, you always do the second one minus the first one. Okay. And so it's very simple. And in the same way, to find the magnitude, it's the same thing. We just take the square root. This is the distance formula, all it is. However, notice that what I have here is the order of the coordinate representing the vector is important, basically, not so much in the distance formula. That we've learned that doesn't really matter. But when we're representing this equation as an ordered pair, all right, the order does matter, all right, because if we were to flip it around, all right, if this 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 vector is a lot different than a vector that's going the opposite direction. That's going something like this. Those are different vectors, all right? So it does matter in which order we do this because it matters what the direction of our vectors. Remember we said two important things of vectors are their magnitude, their size, and their amplitude, all right? Their direction, okay? All right. So here we go. It says find the ordered pair that represents the vector from A to B, then find the magnitude of AB. Notice that A comes first. A is the initial point, B is the terminal point. So we want to express it as a ordered pair. We want to subtract the second, your terminal side minus the initial side. So 0 minus 3, or 0 minus 5, sorry, would be your x value. All right, and then negative 3 minus 4 would be your y value. So if we were to draw this same vector, 0 minus 5 is negative 5. All right, and negative 3 minus negative 4 is negative 7. So let me show you a little bit how this looks. If I graph it real quick. Here's my ordered pair 5, 4. So over 1, 2, 3, 4, 5, and up 1, 2, 3, 4. Here is that point, and then 0, negative 3. So my vector looks like this originally, right? So what we did is we wrote an equation, or we wrote an ordered pair that represents it where its initial point is 0, 0, and its terminal point, its ending point like this, is negative 5, negative 7. So let's check what that looks like over 1, 2, 3, 4, 5, and then down. That was 3, 4, 5, 6, 7. So down here like that. Notice how it's going in the same direction. All right, and the only reason that it looks slightly off is because my drawing is horrible. But it's going in the same direction and it has the same magnitude. All right. And then the next step for this thing to do was to find the magnitude, which if you notice, what we're doing is we're going x2 minus x1, we get negative 5. All right, that would be this part right here. So we have the square root of negative 5 squared plus negative 7 squared, and we'll get its magnitude. So negative 5 squared, that's 25 plus 49. When we add those two, we get 74. So the square root of 74 would be the magnitude of AB. So I believe we denote it like this. The magnitude of AB is square root of 74. Okay? Easy enough, right? We can also, in vectors, we can add, subtract, multiply vectors by scalars when they're represented as ordered pairs. The rules for this are very similar to matrices. That means we're going to add and subtract x values and then also add and subtract y values, just like you do in the same row and columns as a matrix. Okay. So for an operations with a vector A and a vector B, if we were to go A plus B, it would be obviously the x value here plus x value, or the x value minus x value, depending on what your operation is, and then the y values plus the y values. All right. If we were to multiply by a scalar is just a constant. We're calling it k. So like say I had a vector, say if the vector A was 5, 4, so it went from 0, 0 to 5, 4, like that. If we wanted to multiply that same thing, we want to scale that thing by 1/2. That's why it's called a scalar. All right, we just multiply each thing by 1/2. So it'd be 5 halves 2, and that would be our new ordered pair. Go from 0 over to the right 5 halves, and then up 2 would be our new vector. Okay, so this stuff's fairly simple, especially when you already know what matrices are or how to work stuff with matrices. Okay, so in this case, if the vector u is 1, negative 4, and the vector v is 0, 8, find each of the following. So we're adding vector u and vector v. So we add the x's, so 1 plus 0 is 1. Add the y's, negative 4 plus 8 is 4. So there we go. U plus v is that. U minus v, it'd be 1 minus 0, which is 0. And then negative 4 minus 8, which is negative 12. Easy enough. And then again, here we have a scalar. 1/2 of the vector v, so number 3. 1/2 of v would be 0 times 1/2, which is 0. And 8 times 1/2, which is 4. All right. All easy enough. One last thing to talk about is what's called unit vectors. We had a little bit of this when we talked about matrices. But what a unit vector is, what we call the I vector. All right, what the I vector is it's one unit on the x-axis going this direction. All right, it's one unit going that direction on the x-axis. That's I. That's the I vector. The j vector then, if you could guess, is one unit going up in this direction. That's the j vector, all right, going in the y direction, okay? So and these are both 1 units, all right? And so we just talked about scaling something and multiplying by a scalar. So what we can do is we can take an ordered pair of a vector and write it as a sum of unit vectors. And what this means is, say I have an ordered pair 5, 4 again. I could write this as a sum of unit vectors and say it's 5i plus 4j. And what that means is it's 5 units this way, 5 i's this way, and it's 4 j's this direction. And then I need one more arrow, and then you connect the dots right there. And that's all it's saying. All right, and the reason we do this is because we can do some things with matrix properties and stuff like that, and we can write these as matrices and do different operations like that. So it says write AB, the vector AB, should have a line there, as a sum of unit vectors for the 2 points here. Well, first off, we got to write AB as an ordered pair. And how we do that is we take the terminal side minus the initial side. All right, so -1 minus 2 for the x values, and it'd be 5 minus -7 for the y values. So -1 minus -2 is -3. 5 minus -7 is 12. All right, so there's its ordered pair. There's AB's ordered pair. And then to write it as a sum of unit vectors, all it is it is negative 3I plus 12j. And that's all it is. And we're just going to start with that. And from there, in the following sections, we'll learn about matrices and how to use that, stuff like that. Hope this helps. We'll see you in class.